because machines are good at a certain number of tasks that they have all the underlying intelligence that we assume a human having those capabilities will have, right? We're fooled into thinking those machines are intelligent because they can manipulate language. And we're used to the fact that people who can manipulate language very well are implicitly smart. But we're being fooled. Now, they're useful, there's no question. We can use them to do what you said. I use them for similar things. Great, they're great tools, like computers have been for the last 5 decades. But let me make an interesting historical point. And this is maybe due to my age. There's been generation after generation of AI scientists since the 1950s claiming that the technique that they just discovered was going to be the ticket for human-level intelligence. You see declarations of Marvin Minsky, Newell and Simon, Frank Rosenblatt, who invented the perceptron, the first learning machine in the 1950s, saying like, within 10 years we'll have machines that are as smart as humans. They were all wrong. This generation with LLM is also wrong. I've seen 3 of those generations in my lifetime, okay? So, it's just another example of being fooled. And in the 50s, Newell and Simon, pioneers of AI, came up with a program that said, well, really what humans are doing is in reasoning is really a search, right? Every reasoning can be reduced to a kind of search. So you formulate a problem, you write a program that tells you whether a particular proposal for a solution is a solution to your problem, and then you just have to search for all possible combinations, all possible hypotheses for one that actually matches, satisfies the constraint. And that's it. We're going to write a program that does this, and we're going to call it the General Problem Solver, GPS, 1957, I think. They won the Turing Award for things like that, and it was great. But then they didn't realize that all the interesting problems actually have a complexity that grows exponentially with the size of the problem. So in fact, you can't really use this technique to build intelligent machines. It can be a component of it, but it's really not the thing. Simultaneously, Frank Rosenblatt came up with a perceptron, a machine that could learn. He said, if we can train a machine, then it can become infinitely smart. And so within 10 years, we just need to build bigger perceptrons, right? Not realizing that you need to train multiple layers, and that turned out to be difficult to find a solution for this. Then in the 1980s, there was expert systems, okay? Reasoning is fine, just write a bunch of facts and a bunch of rules, and then just deduce all the facts from the original facts and the rules, and now we can reduce all the human knowledge into this. The coolest job is going to be knowledge engineer. You're going to sit down next to an expert and then write down all the rules and the facts and turn this into an expert system. And everybody was excited about this, and there were billions that were invested. Japan started the 5th generation computer project, which was going to revolutionize computer science. Complete failure. Okay, it created an industry. It was useful for a few things, but basically the cost of reducing human knowledge to rules was just too high for most problems, and so the whole thing collapsed. Then there was neural nets, the second wave of neural nets, 1980s, which we now call deep learning. A lot of interest, but then it was before the internet. We didn't have enough data. We didn't have powerful computers, and now we're going through the same cycle again, and we're getting fooled again.
So just to be, Adam, please.
In technologies, every dawn has before it false dawns. That doesn't mean we'll never hit the dawn. I guess I would like, Yann, if you think that LLMs are going to saturate, what is a concrete task that they will never be able to do? That an LLM augmented by the tools we give it today will never be able to perform.
Clear out the dinner table, fill up the dishwasher.
Okay.
And that's easy compared to...
I'm skeptical.
That's super easy compared to fixing your toilets.
Yeah.
Okay, so a plumber, right? You're never going to have a plumber with LLMs. You're never going to have a robot driven by LLMs. it just cannot understand the real world. It just can't.
So I want to clarify for the audience that you're not saying that machines or robots won't be able to do this. That's not your position. You think they will.
They will. They
But
absolutely
just
will.
not by
If-
this algorithmic approach or
That's right.
this particular approach of the deep learning on the neural
If the
nets.
program I'm working on succeeds, which may take a while.
This is JEPA. Am I
JEPA, right? JEPA and you know all the things, world models and things that go with it. If it succeeds, which may take several years, then we may have AI system. There's no question that at some point in the future we will have machines that are smarter than humans in all domains that where humans have abilities. There's no question about that. It will happen. Okay, it will probably take longer than some of the people in Silicon Valley at the moment are saying it. It will. And it will not be LLMs, it will not be generative models that predict discrete tokens. It will be models that learn abstract representations and make predictions on abstract representations and can reason about what is going to be the effect of me taking this action, can I plan a sequence of actions to arrive at a particular goal.
You call this self-supervised learning.
No, so self-supervised learning is used also by LLMs.
Mm-hmm.
Self-supervised learning is the idea that you train a system not for a particular task other than capturing the sort of underlying structure of the data you show it. And one way to do this is to give it a piece of data, corrupt it in some way by removing a piece of it, for example, masking a piece of it, and then training a big neural net to predict the piece that is missing. So LLMs do this, right? You take a text, you remove the last word, and you train the LLM to predict the word that is missing. You have other types of language models that actually fill up multiple words. They turn out to not work as well as the ones that just predict the last one, at least for certain tasks. You can do this with video. If you try to predict at the pixel level, it doesn't work, or it doesn't work very well. My colleagues at Meta probably boiled a couple small lakes in the West Coast to trying to make this work. To cool the GPUs. So it simply doesn't work. So you have to come up with those new architectures like JEPA and stuff like that. And those kind of work. Like we have models that actually understand video.
And Adam, are people